This is Edexcel Further Maths, Further Pure 1, Specimen Paper, Question 3. This asks us straight away to use the substitution t equals tan x over 2. So before we even begin, we know we're dealing with the t-formulae. And so before I even read the rest of the question, I'm going to sketch for myself the triangle that I'm going to be making use of here. All I'm going to do is draw myself a triangle, nice little right angled triangle, and I'm going to use the fact that I can remember the various side lengths to reproduce for myself all of the standard results for the tan t formulae. Basically, we should end up with sides of 2t, 1 minus t squared, and 1 plus t squared. So if I put those on my diagram, from there I should be able to reproduce quickly and easily for myself the required results. 2t is the opposite side, the side opposite the angle we're interested in. 1 minus t squared is the adjacent side, and 1 plus t squared is what it looks like, the largest of the three sides. Remember, in this scenario, the angle itself that we're dealing with is x. So just like in the question, they've got tan of x over 2. This triangle is not the triangle where the angle is x over 2. Rather, this triangle is the one where the angle is x. And that's where the t-formulae really come into their own. We end up with a formula for sine x, which is just 2t over 1 plus t squared, opposite over adjacent, opposite over hypotenuse rather. We get cos x, which is going to be 1 minus t squared over 1 plus t squared. That's adjacent over hypotenuse. And finally tan x, which is going to be opposite over adjacent, which will be 2t over 1 minus t squared. So now we've got those sorted and ready for us to use. We have show that the equation 4 tan x plus 3 cot x over 2 sec squared x over 2 equals 0 can be written in this form. In other words, as a quartic, or if you like, a quadratic in t squared. So all we need to do is find a way of replacing these functions with something involving t. Well, one of these, straight away, tan x, is one that appears here. Tan x can immediately be turned into 2t over 1 minus t squared. But what about the rest? Because we also have a cot and a sec squared. And these, slightly different, because these still have an x over 2. We don't have results here for cos of x over 2 or sine of x over 2, let alone cot or sec. But if the angle is the same as this, then all we're using is standard trig identities for the other bits. So we'll get to those parts one at a time. We'll look at cot x over 2 first, and hopefully we notice that cot is the reciprocal of tan. So all we're going to need here is 1 over tan of x over 2. And in this case, that means 1 over t. We can also get for ourselves something involving sec squared. We need to remember that sec squared is equal to 1 plus tan squared. And that's true regardless of what the angle is we're dealing with. And in this case, that means 1 plus t squared. So we can turn our equation into 4 lots of 2t over 1 minus t squared plus 3 lots of 1 over t times 1 plus t squared. This is going to take a bit more simplifying to get it in the required form, but the first thing to notice is that you've got fractions, so we can multiply by their denominators. I'm going to multiply through by 1 minus t squared and by t. So 4 times 2t over 1 minus t squared, we lose the 1 minus t squared, we introduce a t, we're going to get 8t squared. For the next term, the t disappears, and we also get a 1 minus t squared term. We still have the 1 plus t squared from before, and we've got n equals 0. Now, to get it in the form they're describing, which is an expanded quartic with t to the 4, t squared, and constant terms, I'm going to need to expand these brackets. But fortunately, we've got a difference of 2 squares. So 8t squared plus 3 lots of 1 minus t to the 4. And when we simplify that a little bit, we can see we can get minus 3t to the 4 plus 8t squared plus 3. And there's only one final change required. We see that we can change the sign of every term on the left. Because we've got a 0 on the right, that doesn't change the right-hand side. And we've demonstrated that we've got the equation they asked us for in part A. For part B, they've asked you to solve this equation using what you've already found. Now, in this case, this makes perfect sense. We've got a simpler way of describing the equation we were given. The original equation looks the same as this. Sometimes there'll be a slight difference. Perhaps they would have given tan 2x and cot x and sec squared x, but in this case, it is identical. It's worth checking to see if there are any transformations that have taken place. It's quite common on maths or further maths papers for a small change to happen between part A and the hence in part B. In this case, we're going to use exactly that, which means the solutions to our equation involving t will correspond directly to solutions for this one. Just bear in mind when you found the values for t, you still have a little bit of work to do to find values for x, because t is not the same as x. T is equal to tan of x over 2. So let's solve the equation. The simplest way to do this is to make use of the calculator function. If you go to the mode A for solving polynomials, you can solve as a quadratic, and this is probably the nicest way because then you don't lose any of the proof that you're trying to generate. You want this to be clearly demonstrated, you want to know where you're coming from, but the examiner is quite happy for you to use a calculator to aid you in, for instance, factorizing a quadratic. The roots come out as 3 and minus a third in this case. So we could even, if you like, write this as 3 times t minus 3 times t plus a third. So we're making use of the fact that the roots are 3 and minus a third, but I'm incorporating the fact that there's a 3 in front so that I'm not losing information there. In this case, it doesn't matter so much because it's equal to 0. The main thing is I've got t equals 3 and t equals minus a third. However, one thing I've missed, and this is the potential issue with looking at this and saying, oh, it's a quadratic. The step in between here is that this is 3t squared squared minus 8t squared minus 3. So although the calculator is perfectly valid in its results here, what I'm doing by putting the numbers in here is assuming that values for x will give me the solutions I'm looking for. In reality, what they're giving me are values for t squared. So when I get to here, I've found that t squared is either 3 or minus a third. And we can see that only one of those is going to give valid solutions. So we can say t squared equals minus a third gives no valid solutions. Doesn't matter what t is, you can't square it to get minus a third if we're within the realm of the real numbers. So we're left with t squared equals 3. And this gives 2 possible values for t, plus and minus root 3. And before we finish, we need to remember that means tan of x over 2 is equal to plus or minus root 3. So we're not quite there yet. We now need to figure out what's going on with x over 2 by looking back and seeing what we're asking for here. Between minus 2 pi and 2 pi, they're the values of x that we're interested in. So we now know if x is between minus 2 pi and 2 pi, inclusive at the top end, so I'll need a less than or equal to here. That means that x over 2 will need to be between minus pi and pi. Well, that should make our life a little bit easier. All we need to do here is solve each of our two separate equations. So we have tan of x over 2 equals root 3. We can get x over 2 from that. Remember, the calculator can help you with this. Inverse tan of root 3 is a standard result, but if you are a bit rusty on that, then, or even if you just want to be doubly sure because you're in an exam situation, then I would highly encourage you to check with the calculator. Inverse tan of root 3 should give us 60 degrees or pi by 3 radians. So we can put x over 2 equals pi by 3. I know I should be in radians because it was talking about pi in the beginning of the question. So that's a given. Now that's only the first solution. We can also find additional solutions simply by adding or subtracting multiples of pi. Now if we add pi, we get 4/3 pi. And that's beyond the range that we want for pi by 2. So instead, we try subtracting pi. So if we subtract pi from pi by 3, we get minus 2/3 pi. Of course, this you could do without the calculator as well. We've got nice multiples of pi. We can't get any further because if you move down another pi, you're going to go beyond the range. The range is only from minus pi to pi. We're already pushing the boundaries with a minus 2 pi by 3. For the next one, minus root 3, we can probably guess what this is going to give us. Again, to be on the safe side, don't forget your trusty calculator will help you to double check that your instincts are correct. We should be getting minus 60 degrees or minus pi by 3. And as usual, you can add or subtract multiples of pi. So in this case, there's no point subtracting pi, but we can add pi and we'll get 2 pi by 3. So we now seem to have found for ourselves quite a few different values that appear to be valid. But remember, these are values for x over 2. That's why I've carefully made sure I've included x over 2 equals for each one, so I don't forget. When we get close to the end, it's tempting to say, great, I'm done, I've got my solutions. We need values for x. So x is either going to be 2 pi by 3 or 4 pi by 3 at the top end, or we've got minus 4 pi by 3 or minus 2 pi by 3. So in order, minus 4 pi by 3, minus 2 pi by 3, 2 pi by 3, and 4 pi by 3. And the final step I want to do here is to go back, check the question, make sure we've answered what we were asked. It said give your answers in terms of pi. Encouragingly, we got nice exact values from the calculator. So we've got our values, minus 4 pi by 3, minus 2 pi by 3, etc. They're all in terms of pi. They are within the range. So the largest one is just a bit bigger than pi. The lowest is a bit lower than minus pi. And the last thing we can do is use the calculator to check our answers. We go to menu option 9. So that's in here, the table mode. Once you're in table mode, you can enter any algebraic expression that the calculator can understand in here. So we're going to enter this, 4 tan x plus 3 cot x over 2 sec squared x over 2. We have to be a little careful because cot and sec are not functions that are explicitly given on the calculator, but we can still work them out here. 4 tan x plus 3 over tan x multiplied by, and then for sec squared we'll have 1 over, and we'll need to open brackets and do cos of x, close brackets, squared, close brackets. If in doubt, use more brackets, but make sure you know exactly where your brackets start and finish. And then g of x we don't need, or in this case we can put a 0. If you had some complicated equation with stuff on both sides, you could put the right hand side in here. Now it doesn't really matter what I put here to start with, so you can just hit equals, and what we're going to find here is it's going to sub in the values 1, 2, 3 and 4 and so on. What we can do next is put in the values that we think are the solutions. Minus 4 pi by 3, type it in directly and press equals. We can check to see whether that solves the equation. Now it didn't work here, which either means I've messed up the question or I've messed up the input, and I have a feeling I know what happened. I think we messed up the input. When we were first putting those numbers in, what probably happened was I didn't do the x over 2 bit. So we've got to double check that first, because the most likely thing is that your verification step wasn't quite right. 4 tan x plus, and this will be 3 divided by, we'll put both those bits on the bottom now, we'll have tan of x over 2, and we're also going to multiply here by the square of cos of x over 2. So I'll put x over 2 in a bracket, squared, close brackets. That's on the bottom of a fraction. G of x can be 0. That's what I'm hoping to get out when I put the correct numbers in. And then again, we're going to try minus 4 pi by 3. And reassuringly, that one works. Now we can try minus 2 pi by 3. If you're pressed for time, just trying one or two of these at least will show you that you're on the right lines. But if you want to check that all your solutions are correct, the value of the table function is you just need to make sure you type it in carefully and properly the first time. And when you're confident that you've typed it in properly, you can just put whatever numbers you want to test in here and you'll be able to find them. If you've made a mistake with one of your solutions, then you'll see it because it'll show up on the screen as the left and right hand sides of your equations not matching. And you'll know for sure as a result that you've made a mistake with the particular one that didn't work there. You can go back and fix it.